Once a continuous foaming line is installed on set, being able to start the machine and produce foam is only the first step. What really creates the gap is whether the line can still stay stable after running continuously for days or even weeks, and whether the production result can still remain consistent. This is where the value of the control system really shows up. The control system covers many things: raw material temperature, flow rate of each component, feeding pressure, mixing speed, and conveyor speed. These parameters are distributed across different parts of the line, but in the end, they all come back to the same question: is the production condition stable, and is the result staying consistent, or starting to drift? Let's start with temperature. Once raw material temperature changes, viscosity changes with it. Once viscosity changes, the metering condition also changes. And after that, the mixing condition and reaction rhythm will be affected as well. So the role of temperature monitoring is very direct. It helps detect early that the raw material condition has already started to change, so the set can respond in time and keep that change from continuing into the later metering, mixing, and foaming process. Flow rate and pressure are equally important. Once the flow rate or pressure of one component begins to fluctuate, the actual feeding condition entering the mixing head will be affected. Continuous foaming is different from one-time molding. Once a deviation appears, it usually does not stay in one place. It continues moving forward with the production process. So the core value of flow rate and pressure monitoring is to see in time whether the feeding condition has already started to change. What really tests a control system is whether it can keep these parameters coordinated. If raw material flow changes, the mixing condition usually has to be judged again. If the creaming and rise condition changes, the conveying rhythm also needs to be checked again. Sometimes on set, each individual parameter may still look normal, but the result of the whole line has already started to change. In many cases, the problem is that the coordination between parameters was not adjusted in time. This point is very important at the project operation level. If the system has strong coordination capability, the production condition is easier to keep stable, and fluctuations during shift changes or operator changes are also easier to control. If the coordination capability is weak, the set becomes much more dependent on individual experience, and result consistency becomes harder to maintain. Then there are alarms, interlocks, and protection. What this part really affects is whether an abnormal condition can be stopped in time. In continuous foaming, once one section goes wrong, if the whole line continues running, what gets affected is often not just one point, but a whole section of production. So whether alarms and protection are sufficient directly affects how far the loss can spread, and also whether the set can move into effective response quickly enough. The operator interface is also important. It affects not only parameter setting, but also on-set judgment. If the interface is clear, key conditions are easier to read, and abnormal changes are easier to spot. If the interface is confusing, the set response is often one step slower. This kind of difference may not look obvious during normal production, but once the line begins to fluctuate, it becomes much easier to notice. On equipment with a higher level of automation, there may also be functions such as formulation storage, historical records, formulation recall, and switching. The most practical value of these functions is to reduce repeated trial and error, shorten the adjustment time when changing formulation or operating condition, and also leave a basis for later troubleshooting and traceability. So when evaluating a control system, there are three main things to focus on. Can it detect changes in condition in time? Can it keep the key parameters coordinated? And can it make production results easier to keep consistent? For long-term stable operation, the control system is often one of the key dividing lines. But even if the front section and the control system are both well managed, the whole line still cannot stay stable if the back end cannot keep up. In the next episode, we will continue with cutting, curing, temporary storage, and transfer, and look at why the back-end can also affect the running rhythm of the whole line. If you want to understand the 7 key factors that affect the long-term stable operation of a continuous foaming line, please leave your email in the comments, and we'll send you the document later.